Okay, so there's some significant differences between 1 and 2. Same directions, factor and solve, but 2 is longer than number 1. And what it has to do with is the letter A. So this goes A, B, C. So in this situation, A is 1, B is -15, and C is 56. When you're asked to factor and A equals 1, it's a shorter process. On number 2, A is 12, B is -11, and C is -5. When you're asked to factor and A is not 1, it's a longer process. And that's because there are fraction answers. It's more difficult to come up with those fraction answers. So number 2 has like 4 more steps than number 1. So after I go over these 2, you're going to kind of pick and choose. This handout is separated in half. There's several problems like number 1, the shorter process, and that's where you're at today. Practice those. And then there's several problems like number 2, the longer process. If you're feeling like you're ready to take that on, you do those. So this is all we're practicing today for classwork. These two problems.
Do we have a test coming up?
You don't.
Oh.
There's no test this week. Yeah.
Wasn't it like November something?
The chapter 3 test was originally scheduled for November 1st. So let's put that back like at least 5 days. Yeah. The schedule is just shifted. Nothing's going to be like smushed or anything. Alright, so here we go. I want to remind you that what we're doing is finding x-intercepts. So when I solve this, I'm looking for the x-intercepts, which are called roots. They're called zeros, and they're called solutions. Alright, so for number 1, I'm going to make a little table. What I want to figure out is I need to figure out how to break these numbers apart. I want numbers that will multiply to the C number, which is 56. And that will also add to the B number, which is -15. So I'm hoping to find some combinations of numbers that will work for both of those. So I just start listing everything. Let's start with 1. 1 times 56 makes 56. But there's something interesting here. We have a positive last number and a negative middle number. So that's an indicator that something needs to be negative here. So now a positive 1 times positive 56 makes 56. But you know what else will make a positive? When you multiply 2 negatives together, you get a positive. So you might want to also consider the same numbers but both negative. I think 7 and 8. So we could do 7 times 8 or -7 times -8. I think these are all of the combinations that could possibly multiply together to get 56. I'll now add them to find the ones that add to be -15. 1 plus 56 is 57. That's not it. -1 minus 56 is -57. That's not it. 7 plus 8 is 15. I'm thinking that's it. However, I have to be really careful about the signs. I'm looking for a -15, so I'm still going to have to play with the signs a little bit. Maybe I'll try this one. -7 minus 8 is -15. Those are the numbers that work. They satisfy both criteria. After you find your numbers, you're going to write your 2 parentheses. Factored form is like intercept form. You put your letter in. This time it's X. Sometimes they'll use M or N or T, but we put your letter in. And then since we picked -7, we're going to write X minus 7, -8, X minus 8. If the directions just said factor, we would be done right now. That's now factor. The nice thing about factoring is you could always check. You're not required to. But if you're like, man, I don't know if I got those signs right, I can't figure that out, you can always take a little side note and check it. If you want to check because you're not feeling too confident about the signs you picked, you just distribute or FOIL. I would do x times x is x squared. X times negative 8, negative 8x. Negative 7 times x, negative 7x. Negative 7 times negative 8, positive 56. And that checks out. That's exactly what I started with. So you can always, a lot of students, they think they come up with the numbers, and then they just try different signs, and they FOIL it until they figure it out. Okay. Now, the directions say factor and solve. So I'm going to go one step further, and I'm going to do the and solve part. We'll do x minus 7 equals 0, x minus 8 equals 0, and solve these binomials. They're called binomials because there's two terms in the parentheses. So I get x is 7 and x is 8. Any questions on number 1? Another way to check this is to use Desmos. Now look at this. X squared minus 15x plus 56. So here's Desmos. Does my 7 and 8 appear when I type in the problem into Desmos? It's on. Yeah, right here I see x equals 7, and right here I see x equals 8. So those solutions are present right there on the graph. So you are supposed to show comprehension about standard form, moving into intercept form, solving it, knowing what that looks like on a graph. All those things should tie together for you. Questions on number 1? All right, let's try a longer one. Number 2. And again, the reason this process is longer is because somehow we have to incorporate this 12 into the process. We want to kind of do exactly what we did with number 1, but we have to account for a 12 in the beginning. So this is called A times C method. So in order to get the 12 involved, we're going to do 12 times negative 5, that's A and C. That's negative 60. So in the little table, instead of finding numbers that multiply to negative 5, we find numbers that multiply to negative 60. Yeah. Yep. So I'm going to list everything that multiplies to negative 60. And I see students a lot of times sit there and they say, I can't find the numbers, but they never attempt to actually write a complete list. Your list is your tool that helps you come up with the numbers. It's not staring in the air. I mean, we can't think about the numbers mentally, but if you're stuck with that, write a list down. I'm going to try 1 times negative 60, 2 times 30, 3 times 20. Get your calculator out. 4. Does it divide by 4? 4 times 15. 5. Does 60 divide by 5? Get your calculator out. Put it in a calculator if you're not sure. 5 and negative 12. 6. 6 times negative 10. 7? 7 times. No, 60 doesn't divide by 7. 60 divided by 8. 60 divided by 9. Check in your calculator. 65 by 10. Yes, 10 is there. 11? No. 12. This is a complete list. Can anybody else find numbers that multiply to be 60? Okay, now I'm going to add them up and see what I get. That's negative 59. Negative 27. No, that's negative 28. Negative 17. Negative 11. That's what I'm looking for. All right. I found my numbers for negative 15. Now, if this was like number 1, I would be going to parentheses with those numbers, but it's not. It's more complicated, so I'm actually going to rewrite the problem using the numbers that were picked. Start the problem over. We're going to use these numbers that we're picking. And where we're going to put them, we're going to put them in the B spot. So we're going to use the pick numbers instead of B. So it was originally 12x squared minus 11x minus 5. I'm going to change it to 12x squared plus 4x minus 15x minus 5. It's equivalent. If I combine like terms, I get what I started with. But I've rewritten this into something that's more useful. With 4 terms in the problem, it's easier to work with. With 4 terms, you can split it into groups of 2. So we're going to factor by grouping. So I'm going to look at 2 at a time now. And that actually makes everything easier. You can just do 2 at a time instead of 3 or all 4. You factor by grouping, you're looking for GCFs. Greatest common factors. Falling back on your greatest common factor skill. What do 12 and 4 both divide by? 4. These first two will also have a letter in common. This one has x squared and this one has x, so we can pull an x out as well. So when you take a GCF out, it's like dividing both of them by the greatest common factor you pick. So 12 divided by 4 leaves us 3. It was x squared, but we're going to factor an x out, so I have 3x. The GCF exactly matches the second term. So 4x divided by 4x is 1. You have to put a 1 in there. Remember, when you're factoring, you're just rewriting. So when I distribute this back in, I should be able to get what I started with. So you have to have a 1 there. Question so far. This GCF part is really got to make sense. So now I'm going to cover up those first 2 terms, and I'm just going to focus on the second group. I just focus on 2 at a time. So what's the common factor between 15 and 5? They both divide by 5. Now, in this situation where they're negative, you take out a negative. So our greatest common factor of these 2 will be negative 5. $15 divided by 5 is 3. There's still an x there. Negative 5 over negative 5 is 1. The parentheses must match. If your signs don't match or something's not right, go back and try again. They have to match. One last step to get to the factored form, and that's to put the 4x and the minus 5 together. Keep one of the matching sets. And that's not factored. And I can kind of look it over and think it in my head, but 4 times 3 is 12. Right, I can see that 12x squared. 5 times 1 is 5. I can see that negative 5. So, alright, let's do that last step and solve. 4x minus 5 equals 0. 3x plus 1 equals 0. Add 5 and we get 4x equals 5. Divide by 4. And we have an answer at 5/4, or 1.25. Subtract 1. 3x equals negative 1. Divide by 3. And our second x-intercept is negative 1/3. In those fractions is why this process is longer. It's more difficult than number 1 coming up with the numbers that work because of the fact that it's actually fraction x-intercept. Let's go ahead and check if these fractions show up in Desmos. It's 12x squared minus 11x minus 5. Alright, so where do we see x-intercept? So negative 1/3 is negative 0.3. Yep, that's 0.5, there's 0.3. And 5/4 is 1.25. So this is 1.1, 1.2, 1.3. So they're still there. They're just more difficult because they're fractions or decimals. Who's got a question on number 2? Okay. So that's the 4th time I've gone through that process with you guys. A times C method, and you have that handout. What I will tell you is that this shows up in every chapter of the textbook. Okay, you'll use this to solve in every chapter for the rest of the year. So really try to work to figure it out. Today's handout, like I said, is in 2 parts. The first half is the simpler method when a equals 1. The second half is the more complicated method. You do not have to finish this for homework. You just have to work on it till the end of class. Okay, so everybody in here works at a different pace, whatever you can get done in class. So when I walk around tomorrow, I just want to see the effort you put in class today. You do not have to finish it for homework.